Okay, this is a learning video in which you are going to learn how to draw and how to name organic molecules with what we call functional groups. And a functional group is a classification of organic molecules. And they have a specific amount of elements that would be part of that functional group. The first functional group we're going to talk about is an alcohol. And an alcohol contains an OH, so an oxygen and a hydrogen bonded together in the organic molecule. Now sometimes you're going to see that OH written just as is, like an OH, but you can also see it written like that. I want you to know that there is a bond between that oxygen and that hydrogen. Just for organic sake though, we shorten it up and it's typically written just as an OH. That is what we call the functional group. So it's kind of the look for how you're going to be able to classify this particular group of elements as or organic compounds as an alcohol. So I'm going to circle the functional group, and that's called an OH. It's actually called a hydroxyl group. You'll learn that as you take more organic chemistry, if you choose to take more chemistry in college. So naming an alcohol or classifying an alcohol, you're going to know it's an alcohol because it ends in the word ol, O-L. So let's take a look at the first example here, which is methanol. So methanol, again, we look at the meth meaning one carbon, OL meaning that it is an alcohol. So if it's an alcohol, it has to have that OH group in it. So you're going to draw one carbon, and then you're going to draw that OH group. And that is the molecular structure for methanol. How would you count its molecular formula? Well, again, we're going to put the molecular formula, you put the carbons first, then the hydrogens, and then everything else. So there's one carbon in this molecule, so that's a C. We're going to count how many hydrogens there are. And what's unique about alcohols is that their molecular formula kind of shows the structure. So this carbon right here would have 3 hydrogens attached to it. So I'm going to write CH3, and then I'm going to write that OH. This is the molecular formula for an alcohol. And you can see with having that OH there, it lets you know that this is an alcohol. Now, would it also be correct to write CH4O? And yes, it's just not as informative for the organic chemist. So typically that OH is written as a group together for alcohols. A second type of carbon or alcohol that we're going to talk about is ethanol. Eth meaning that you have 2 carbons and you have an OH group attached. Now that OH group could be written like this. This is the same thing. And if I take this and I were to, turn it upside down and I have that OH written in the first carbon, notice that still is exactly the same thing. It's called ethanol. All right? So now with ethanol, its molecular formula would be C2H5OH. That's the typical way we write the molecular formula for ethanol. Now when we get to propanol and we look at what prop means, remember the prefix prop means 3, and we know it's an alcohol because it ends in OL, so there has to be an OH group in it. When I write 3 carbons, I could put that OH on the first carbon, and so therefore I call that 1 propanol. That is different from this structure, which is called 2 propanol. Notice the OH group is on the second carbon, so it has a different name. Do they have the same molecular formulas? Yes. Yes, they do. Let's take a look. You've got C3H, 2, 3, 4, 5, 6, 7, 8. Is that right? Let's look at the molecular formula for this. C3H, I have this written down, H7OH. And this molecular formula is C3H7OH. So they have the same molecular formula, but the structures are different. If you would recall in an earlier slide, we call those isomers. Isomers means same molecular formula, different structure. So there is a physical property that is different between 1-propanol and 2-propanol. Like boiling points, melting points, those kind of things are different. All right, so that is how you name alcohols and how you draw alcohols. Let's look at another organic group or classification, and they're called ethers. An ether has an oxygen, and that oxygen is between carbon atoms. You're going to know it's an ether because it ends in the word ether. And right here I have the picture of what an ether, the general formula of what an ether looks like. And what I forgot to mention in the earlier slide as well is that this R can represent any number of carbon atoms. So that R could be 1 carbon or it could be 10 carbons. It's the generic formula for an ether. The look for is that you've got an oxygen kind of in the middle sandwiched between a bunch of carbons. Okay, so a simple ether would be something like dimethyl ether, and dimethyl ether would have that ether functional group there, so you know there's an oxygen in there. And the fact that it says it's dimethyl means that there is one methyl group on one side of the oxygen, and there's another methyl group on the other side of the oxygen. Its molecular formula we're going to put as C2H6O. When we look at methyl propyl ether, here's my ether functional group. On one side, there is a methyl. On the other side, there is a propyl. And this molecular formula would be C4H10O. So that's where I'm just counting up all the carbons, and I'm counting up the hydrogens and placing the elements in the molecular formula. That is how you name ethers. We're also going to talk about how to name amines. Amines are very similar to ethers, except an amine, you will have nitrogen amongst the carbon molecules rather than oxygen. Now, nitrogen will bond with up to 3 carbons, and that is because if you would recall what nitrogen looks like, nitrogen has 5 valence electrons. So as I draw the Lewis structure for nitrogen, it looks like that. And that means that you have the ability to make a bond, 3 bonds with nitrogen. Whereas in oxygen, you only have the ability to make 2 bonds. If we go back to this slide, here I can show you. When we're talking about oxygens, because oxygen has 6 valence electrons, it only has the ability to make 2 bonds. But nitrogen can make 3 bonds. So that means you can have basically 3 carbon branches off of the nitrogen compound. We call these amines, and you're going to know it's an amine because it ends in the word amine. The simplest amine that you can have would be called a methylamine. So here is my nitrogen, and here is my methyl compound. That would be methylamine, And just to be clear, when we're counting the molecular formula and we're looking at the hydrogens, there would be a hydrogen here and a hydrogen here. And what's really here is a lone pair of electrons. Remember that lone pair of electrons on the nitrogen. So this molecular formula would be CH5N. Because if you would recall, there's hydrogens coming off of that first carbon as well. That's the molecular formula for methylamine. You can have something like a methylethylamine. So in this structure here, here is my amine. On one side, I have a methyl group. On the other side, I have an ethyl group. And what would be coming off of here would be a hydrogen, and I just put that in there for counting purposes. This molecular formula would be C3H9N. You can also have dimethylpropylamine, something like that, where here you've got 3 carbon branchings off the nitrogen, whereas in this example here, you only had 2 carbons branching off. In this example here, you only had 1 carbon branching off. But you can also have 3 carbons branching off. So here's my amine, and there's a methyl here, and on this side is a propyl. So they're very easy to draw, and they're pretty intuitive from the name, how to draw them. What would be the molecular structure for that dimethylpropylamine? You're going to count all the carbons, and you have 5 of them, so it's C5H13N. That is the molecular formula. Okay, so that's it for the first 3 learning video, or the first 3 functional groups that we're going to cover. I think we're going to cover more on the next slide because I'm running out of time here a little bit. So I just want to do a summary of what we've gone so far. So you can have these things called functional groups. And functional groups are a set of atoms that are, or elements that are unique to the organic molecule. The ones that we have gone over in this video are, is if you see an OH, we're going to call that an alcohol. If you see an oxygen kind of stranded in between or sandwiched in between a number of carbons, we call that an ether. And if you see a nitrogen that has carbons branching off of that, that is called an amine. I hope this helps. Tune in to the next video for learning the other functional groups. There's going to be 3 more that we're going to cover. And I hope this helps. Thanks for listening.